Hello. This week we are going to learn about the Chernobyl nuclear disaster that happened in the 1980s. And we're going to talk about some of the environmental aspects, the environmental impact of that. But first I want to just briefly give the scenario. So on April 26th, 1986, there was a meltdown, an explosion that happened at the nuclear power plant near Chernobyl in what is now Ukraine. What happened, we don't have to get into all the details, but what happened was the cooling systems went down, they weren't working properly. It caused the reactor to heat up beyond what it should. All of the heated gas exploded, destroying this building that you see here and sending radioactive material all over the place. So this was in reactor 4. And again, it explodes. Not a nuclear explosion, a regular explosion. But what it did was caused radiation and radioactive material to be launched up into the atmosphere all around this site. So anyways, here's an image from the air. It explodes. Very quickly, they send first responders, firefighters, paramedics, and the such, to see who has been hurt. Because some people were killed instantly from the explosion. The rest that were here, including the first responders, were exposed to a tremendous amount of radiation, okay? In the rest of the surrounding communities that same day, they did not tell anybody what had happened. People knew that there was some kind of an explosion, but they didn't say anything about radioactivity. So people just went about their business. They kept doing what they usually do. Children were still in school or playing in parks. And people were not immediately told. Because of this, because they weren't told what happened, all of this radioactive material and radiation that was coming from that power plant was causing problems for everybody that was not being evacuated or being told to take shelter. So radiation moves through materials, and it would have harmed all of these people that were not evacuated. But radioactive material is like little particles. You think in the explosion, it gets thrown up into the air, and then it starts landing places. Now it's so small that you don't even notice it, but that causes huge, huge problems. What this means is that tens of thousands of people in the area were exposed to radiation. Now this is different than the people that were like the first responders and the people working at the nuclear power plant. They were so close to the radiation that they had severe medical problems within months of the event occurring. So everyone that was around there, that was close by, the majority of them that went to the power plant during this incident, they all died of cancers within a few months. Many of the other people that were close to the incident, they would die of cancers slowly over several years, the cancers would start coming up and showing themselves. So even though that tens of thousands of people were exposed, it's not like all of them developed cancer. Although there is higher rates of cancer in those populations because of the exposure. Now, when we talk about radiation, usually we talk about alpha, beta, and gamma. Gamma radiation, this one down here at the bottom, is the one that we're concerned about, because unlike alpha and beta, it doesn't get stopped by just simple protective barriers. It goes through many of the barriers that would have been in place. Now, when the explosion occurred, it sent particles of radioactive material like cesium-137, which is radioactive, up into the air. And radiation like gamma rays were sent out from the radioactive material. So the cesium-138, those were like the little particles that would fall all over the landscape, and that people could breathe it in, it could get in their eyes, it could cause health problems, long-term health problems associated with cancers. And the radiation, like I said, is just high energy waves. So that went through buildings, it went through trees, it went through clothes, skin, and that had the potential, these gamma rays, this radiation had the potential to mutate DNA, cause cancers. Because when we mutate DNA, that's what we're talking about, is we're talking about developing cancers. It was not until 9 days later that people were evacuated and partially told what was going on. They were evacuated on May 5th, 1986. This was 9 days after the explosion. And they still didn't tell them how severe the radiation was or what kind of exposure to radiation they had been under. They were just told that the town has to evacuate and we'll be able to come back later and get your stuff. So they left all their stuff there, but they never came back to that area. Because what they did was, after they evacuated, they set up a perimeter, a circle around the nuclear power plant explosion. And I believe it was 30-kilometer radius, so this huge area. But we're going to learn in the years since then, they've actually expanded that zone for various reasons, okay? This image shows the explosion in Japan in 2011 at Fukushima nuclear reactor. This is just because we don't have a picture of the explosion in Chernobyl, but this is what it would have looked like. It's not a nuclear explosion. It's not a mushroom cloud like a nuclear bomb going off. It's just a big explosion because of heat and pressure. But that explosion is what sends this debris, which is radioactive material, up into the atmosphere. Now, some of the particles are larger and some of the particles are smaller. So what that means is the larger particles are going to land, because they are larger, they're going to land closer to the site of the explosion, where the smaller particles can get shot way up into the air and land tens of miles away from the site. It can even go further than that. Some of the particles are so small that they get carried by the winds and they can be taken hundreds to thousands of miles away. And that's what happened at Chernobyl. There was a cloud of radioactive debris that got into the atmosphere in the high winds and got taken to other countries, like into Germany or into any of the old Soviet countries like, let's see, Belarus or Poland or Czechoslovakia, into Russia. All that whole area had this kind of debris cloud that slowly settled out. The worst, though, was within probably about 30-mile radius or so. This map just shows kind of that local area that I was talking about, where here's the disaster site, and we have 15 miles that make about an inch is 50 miles. So you're seeing these areas in red still to this day. These are readings that were taken more recently. Still to this day, you have these areas in red that show high levels of cesium-137. And, you know, some of these areas are 100 miles away from the explosion site. Now, they are more concentrated here, probably because of winds blowing that material in certain directions and it settles out. But once that radioactive material, like cesium-137, gets into that soil and the water, it takes a long time for it to eventually degrade. So in this area, you're talking probably thousands of years, or maybe at least hundreds of years before it is safe for people to go back. Now, people could still live there. It's not like you're going to die of cancer immediately. We're going to learn about what's going on with wildlife in the region. But if you did live in this area, in these zones, you would have a higher risk of cancers. It doesn't mean you're going to get cancer right away. It doesn't mean you're going to get a cancer within the year. It's just in the course of your lifetime being exposed to this radiation, you're more likely to get these cancers. Okay, so that's just a little bit about what was going on there. We're going to talk about the environmental impacts after this. All right, thank you very much.